Hi, in this video we're going to talk more about the fuzzy logic and decision nodes. In the previous videos we introduced how to adapt our agents with the terrain ground and how to use the sphere detection of sphere, the range detection, and try to avoid each other. So in this video we're going to do some summarized about the previous videos and talking about more for the fuzzy logic and the nodes, and introduce what's going on inside, so that you can create more and more results and effect in the future production. So let's first open our example 18a, the sphere detection and the terrain free. Let's open that. So in this thing you can see that this is also we are using the simple box agent, and there are some decision nodes already there. There's nothing special. It not exceed anything than the previous videos. These three logical nodes are the sphere range detection and try to avoid each other, and the rest of them is match the ground, adapt to the ground. We are going to talking about what's going on inside of this node, and talk deeper into that. We will not create anything new inside of this video. So you can see that there are some of the logic nodes here. There are two types. The first one is the default decision, and the rest of them are the normal one. And let's first look at any one of the normal one. You can see that there are two parts. The first part is the input condition that defined if something happened. If something happened, we do something. The second part is the behavior we need to do if the input condition activates. So in each one of the decision node, it will iterate all of the agents inside of your thing and test whether this activate or not. If this activates, it will try to do something. The activation value is from 0 to 1. So the 0 or less than 0, that indicate this is not activate, and it will not do anything inside of this. And if that is activate, full activate is 1, and it will do the 150, for example, will execute the fully this value. And sometimes we are using the fuzzy logical because there are some 0 to 1 that indicate the half non-activate and half activate. This can create a result more smooth than the Boolean logic. So this is why we created the fuzzy logic. So if you look inside of each one of the sentence of that, you can see that there are two parts. The first part is the input condition. This input condition will iterate every agent inside of your thing and return a value for that specific agent, and that value will test a range for the rest of the part. And if the range is in the middle of this part, you can see that this is a fuzzy logic range. In the middle of this part, it is actually full activate, and if the outside of this, just like the blank, it's actually non-activate, and in the between them, it's actually the fuzzy range, the activate from 0 to 1 with the float value. So this first part will return the value based on the calculation of our system, and we tested it for a range. For example, in the real example, in this condition, someone in my sphere with an angle, it will return each one of the agents. And for example, if my agent is here, and if there's a real agent in my left, the return value should be about 45, and it's activate this sentence. And if there's no agent in my left, just on my right, and the return value of this should be a negative one, so this sentence is not activate, and it will not do this condition. So you can see that the second sentence is also the same. This first is the something happened. It will return the value based on the current condition, and it will test the range of that. And for example, the distance is less than 60, and the fuzzy range is 15. So the result is the 45 to 75. If the someone is near me and less than 45, it's fully activate. If someone is the far from 75, it's not activate. And if someone is between the 45 to 75, it's half activate and half non-activate, and the return value should be a float point. And we are using the and the condition. That means we need to get the smallest value from this. If both of them fully activate, it will return 1. And if that is the activate, but this is not activate, I will use the less one. So this whole the input will not activate. So no matter what is going on inside of each one of the sentence, there is input activation will be calculated based on this the logic relationship. And this node activation value will determine how big we are going to use this. You can see that there is a default decision, and if all the nodes here not activate, it will execute something else inside of the default decision. So this is how our system working. And then let's talk about the test range. You already know that each one of the sentence will return a value, so we are going to test that with the rest of the language. You can see that some of the language is actually from a value to another, and some is less than something, and some is nothing there. So you may a little bit miss, but they are actually all the same. They are actually is from something to another. We just simplify that to this format, or even something the keywords. You can see that this from 90 to 0 to 90, and this is less than 60. This explicitly indicates 0 to 90, and this is less than 60, means the negative infinity to 60. So you can see that. And with the fuzzy range, it will the plus and minus this value. The 60, the minus 15 is the 45, and the 60 plus the 15 is the 75. And this fuzzy the range of this the boundary, if we just specify this 0, you can see that this is a 60, and the this is a negative infinity to 60. And if we just make that, for example, 1, you can see that this is the 59 to 61. It's actually the fuzzy the boundary of this kind of number, so it can easily create the fuzzy logic. And here we specify the 15, so you can see that the 45 to 75. This is the same. The 0, the plus and the minus 10 is this minus 10 to 10. 0, the minus 10 is minus 10. Is negative 10, and the 0 plus 10 is about 10. And the 90 also we fuzzy the boundary of the 20 is 17 to 11, 110. So if we set that 0 and 0, so you can see that this boundary is very stiff, and this can cause some jitter result fuzzy logic. So this is 10 and about 20. And you can see that in something else, the fuzzy logic, there are something no test range. They're only in the on left or on right, something like this. This is actually an abbreviation, and or the simplified for the regular range is actually the also a range here. You can see that on the right. This is the actually the less than 0, and the fuzzy range is 30. So this is minus 30 to 30. So this is also contain a range. So each one of the sentence will return a value based on the current condition for all of the agents. And for the if the terrain the higher terrain is on right. That means that I need to roll to the left for avoid the higher terrain on the right. And in the later, you can use something else like the bound and in bound. This is actually also has a test range, but we just ignore that because we usually need to fill the same method, the same values. For example, m in bound will return 0 if m not in the bound. M in bound sentence will return the 999 if m really in the bound. So it will test for the 1 and determine if the m in bound, it will return the truth for the entire sentence and return false if it is not in bound because the return value is 0. So we just abbreviate this and for your better understanding and easier observatory. And there's another type of a range test, that is the fuzzy range, fuzzy 2. For example, the noise ID here, you can see that there's this kind of sign. This means the fuzzy 2. That means we're going to fuzzy from 0 to 1. That means if the value is less than 0, it will deactivate, not activate, and it's greater than 1, it is full activate. And if the value between 0 and 1, it will return a float number between them, and the half activate and half deactivate. And we can change this to 0 to 20. So you can see that this is 0 and 20. So it will non-activate less than 0, the full activate the greater than 20, and the half activated and the half deactivated between them. So we can use this to test the range. So you can see that there are several different range tests. The from something, this is explicitly, and less than something is kind of a negative infinity to a value, and something implicitly on the left or right, and something the fuzzy range secure. So this is the range test stuffs. And you may ask the question, how can we know the return value for each one of the sentence? Please trust me, you don't need to recite or remember any one of them. You just need to use our preset, half preset here, and finish everything. In the following video, we are going to talk more and more the logic sentences and the presets for you, so that you don't need to remember anything for that. And if you really wanted to know exactly what is the return value for some specific sentence, you need to use the brain viewer here. And the brain viewer can can show all of the data inside of our decision node. You can see that if we click the different agent, it will return the different values. So you can see that what is the return values and the activation of the current sentence. And for example, let's select any one of them. You can see that the sphere range is the lot of the agents inside of these. The return value may be not very accurate. This is only one values from these two in these several different agents. So inside of this agent sphere range, there are a lot of the different agents. We will choose any one of them for displaying here, but internally we will choose the value can fully activate the sentence. So this is another things about the sphere range detection logic. For the other things, for example, the higher terrain on the left and the right, and this is actually use the single value. For example, we put our agent here and select that again. You can see that the return value is 4.23, and this activates this. It will move down. Okay, and let's just do that. And if we just put it right here and select that again, you can see that m higher than terrain distance is greater than 0 is 90.28. This activates this node, but it will not activate this node, so it will only move down and not move up. So it will try to move down immediately. And in the middle, the both of the nodes will be activated, so it will try to find a middle value between the -20 to the -200 to the 200. So it's kind of the more smooth result. This is the usage of the fuzzy logic. So with the brain viewer, you can understand. I can get the result inside of the our engine. So let's select any one of them and prove out from that. So just right here, you can see that at this time we select this guy. There's this and the -0 to 90 degree, and the 28.8 is activate this sentence, and this 42.52 is also activate sentence. So this sentence is activate, and we're going to turn to the right. You can watch this. It will turn to the right. You can see that. And if we just put right here, this activates this sentence. There's someone in my right. So if we put this into the group, it will return a lot of the other the result. This is not activated. So when you debug, you can just make the two agents inside of here. If you select this, there's nothing in the range because the agent is the back. So and then both of them not activate. So this is a usage of the brain viewer. Okay, this is an introduction for the fuzzy logic, and maybe you cannot understand every detail of this, but I believe in the following videos we're going to introduce the more and more the preset and the usage. Then you can understand everything more and more familiar. Thank you for watching. See you next time.